Richie Cooper.
I'm Matt Berry.
I'm Edgar Madrill, and this is Lab1, kinematic mounts and laser alignment.
Hi, I'm Matt Berry, and I'm going to talk about how we aligned the laser for our lab. So our laser has 4 degrees of freedom that we care about. We don't care about the laser transversing along the the Z direction, or the rotation about the Z direction, but the other 4 degrees of freedom we want to make sure are aligned. So first we make sure our laser is aligned with the table. Doing that, we use an aperture. We move the aperture up close and align the position, the X and Y position of the laser to make sure it's going through the aperture. Then we move the aperture far away from the laser and adjust the rotational degrees of freedom so that the laser is still going through the aperture, and that ensures that the laser is aligned with the table. To make sure that the laser and the table are aligned with gravity or with the floor, we use a pentaprism. We use the pentaprism to divert the incoming laser beam 90 degrees into a tray of water, and if the table is flat with the ground, then the laser beam will go through the pentaprism, bounce off the water, back through the pentaprism, and right back into our laser source. And that's how we... Alright, for the next part of the lab, we used a beam splitter to split our incoming beam into 2 orthogonal beams, and we aligned each of the orthogonal beams the same way we did before, with the aperture along each of our orthogonal degrees. Then we added a second laser in parallel with the first laser, and to make sure it was in parallel again, we used the same aperture trick, as well as measuring the distance between the 2 lasers along several points to make sure it was consistent, to ensure that the 2 beams were parallel. And finally, we used a mirror on our second laser and brought both lasers into our beam splitter. The beam splitter then had 2 outputs from the 2 lasers, and on those 2 outputs we brought the two lasers to overlap each other to ensure that they were aligned right over each other.
So for the next portion of the lab, we align different lenses with respect to the laser beam. We place them really close to the laser and adjusted the knobs so that the back reflection coincided with the input of the beam. And after we aligned a 1000 millimeter focal length lens, a 50 millimeter negative lens, and a 100 millimeter negative lens, positive lens, we constructed a Galilean telescope. We first aligned the eyepiece with respect to the laser beam, and then the objective. And after that, the separation between 2 lenses was 950 millimeters, which is the summation of the 2 focal lengths.
Okay, for the last part of the lab, we wanted to align this microscope with this tiny laser, and basically we had 4 degrees of freedom to control: the tilt, the yaw, the X translation, and the Y translation. So to begin the alignment, we started off with the microscope really close to the laser, basically because it's not so sensitive to rotations, and get the laser into the objective. We chose this objective because it had a small numerical aperture. After trial and error, we kind of realized that. So you align it, and the way that I did it is I used this to tilt it, and then I moved the translation of the Y or the X to align the beam onto the crosshairs.